In this topic, we are going to discuss about parametric function and implicit function. First of all, we just understand what the meaning of implicit function and what is the meaning of parametric function. So we'll compare the difference between the two and we will understand what it means too. So let me take two cases. One is, let's say, implicit function and other is the parametric function. After we understand this, we will think about their derivatives. I'll take a simple example of a parabola. You know, equation parabola is y square equal to 4x. In this, if I write the same parabola's equation can be expressed as the x coordinate of every point of the parabola is 80 square and y coordinate is 280. Which means 80 square comma 280 will always satisfy this equation. If I replace y by 280, x by 80 square will satisfy this. Satisfies this equation. So I can say this is always a point on this. Another way of expressing every point of the parabola can be expressed as x coordinate is 80 square and y coordinate is 280. If I put t as 1, suppose I put t as 1, I'll get a point a comma 2a. If I put t as 2, I'll get the point 4a comma 4a. If I put t as 3, I'll get the point 9a comma 6a. So as I put different values of t, every point of this curve is obtained. So t is called the parameter. That's why the word parametric function has come. As the value of t varies, we can define each and every point on that particular curve. Hence, we call it as parameter. And we also notice that if I eliminate t, if t is eliminated, that means I can write t as y upon 2a. And if I put this t back here, x is a into y upon 2a the whole square. And this will turn to y square equal to 4x. That means a parametric function can be converted to implicit function by eliminating the parameter. By removing the parameter, we can convert a parametric function to an implicit function. These are the points to remember. So what are the points? Every point on the parabola every point on the curve is expressed using a variable t. So there are how many variables in this function? There are 3 variables. One is t, which is common between both of them, and x and y are coordinates are functions of t. So I can say like this. In a parametric equation, x is a function of t and y is another function of t. If you eliminate t, it will come to implicit function. If you remove t from this and form an equation with x and y, it will come back to parametric function. Now the question is, how will I find out the derivative of this function? There are 2 ways. Let me explain to you by using an example. Suppose I want to find dy by dx. In this case, what the formula says is, y can be differentiated with respect to t. Remember, a is a constant, t is a variable. So you can differentiate y with respect to t, you can differentiate x with respect to t, and if you divide, you will get dy by dx. So here, dx by dt is a into derivative of t square. So you will get 280. dy by dt is 2a into derivative of t with respect to t. You will get 2a. So what is dy by dx? dy by dx is dy by dt divided by dx by dt. dy by dt is 2a, dx by dt is 280, so I get answer as 1 by t. So I can say derivative at any point on this function is 1 by t. And you have noticed that the derivative is expressed as in terms of the parameter t. It is not in x and y. You can convert it into x and y, but it is expressed as in t. So whenever you want the derivative to be in terms of the parameter, you must use the formula dy by dt divided by dx by dt. Now let's compare both of them. Suppose I find out the derivative of the implicit function. So 2y dy by dx equal to 4a. So dy by dx equal to 4a upon 2y. So dy by dx is equal to 2a upon y. Now, if I replace y as 280, you can notice that both becomes the same. So, which means both of them implies the same answer. Only thing, in this case, the derivative will be in x and y. In this case, derivative will be in the parameter. So, here is my conclusion. Whenever I want to find the derivative in terms of parameter, you must apply dy by dt upon dx by dt. Whenever you want the derivative in terms of x and y, you must differentiate the implicit function. I hope you understood two methods. One is convert this into implicit function, find the derivative. Another method is take the parametric function, differentiate with respect to the parameter, and divide dy by dt upon dx by dt. You can get the derivative. Both means the same. Depending on how do you want your answer, you use the method. If you want the answer in parametric form, use this method. If you want the answer in x and y, you can use this method. You can also eliminate the t and make it into this. For example, t is what? Y upon 2a. If you replace t as y upon 2a, you will come to this. If you replace y as 280, this will become this. So both means the same. Depending on your answer, we use this method. Now let's take this example. So as I said before, there are two methods. One is you can eliminate theta and then differentiate. Other method is if x is a function of theta, y is a function of theta, differentiate y with respect to theta, differentiate x with respect to theta, and then divide. So here, eliminating theta is not an easy task. You cannot eliminate theta so easily. So since you cannot eliminate theta so easily, so what we do, we use the parametric method of differentiation. So y is a function of theta. So y is equal to a into sine theta minus theta cos theta. So I differentiate y with respect to theta. A into d by d theta of sine theta minus d by d theta of theta cos theta. Now here I have to apply product rule. So I write the answer. Derivative sine theta cos theta minus, don't forget the bracket, theta into derivative cos theta minus sine theta plus cos theta into 1. Derivative theta with respect to theta is 1. So a cos theta and minus cos theta will get cancelled. A into theta sin theta. This is d by d theta. Now let's have a look at dx by d theta. Dx by d theta, x is equal to a into cos theta plus theta sin theta. So when I differentiate with respect to theta, this became a into derivative of cos theta plus derivative of theta sin theta. Now you need to apply product rule here, and here you can directly differentiate and write the answer directly. Minus sin theta plus theta into derivative of sin theta is cos theta plus derivative sin theta into derivative of theta is 1. So I'm not writing that. So again sin theta will get cancelled, and I got the answer a into theta cos theta. So I got dy by d theta, I got dx by d theta. Now I can calculate dy by dx. What is dy by dx? Dy by d theta divided by dx by d theta. So dy by d theta is a into theta sin theta, and dx by theta is a into theta cos theta. So a and theta will get cancelled. You will end up with tan theta. So derivative at any point theta is given by tan theta, but you are asked to find derivative at theta is pi by 4. So dy by dx at theta is equal to pi by 4. How to write that? Like this. You don't have to write word at, but you will read it as at theta is equal to pi by 4 is tan pi by 4, whose value is 1. So derivative at the point theta equal to pi by 4 is 1. What is this point theta is pi by 4? If I want to write in terms of Cartesian coordinate, just replace theta as pi by 4. You will get the x coordinate and y coordinate by using this formula. That's why it is called parametric formation, parametric function. And derivative at the point theta is equal to pi by 4 can be obtained by replacing theta's value over here. Another function we have here, x equal to sine inverse 2t upon 1 plus t square, and y is equal to cos inverse root of 1 minus t square. So to find the derivative of an inverse function, what you have to do first? You have to simplify. Simplify the function and then differentiate. So I need to simplify it. I will not use directly derivative of sine inverse. Here if you want, you can use direct, but here I will not use directly. So what I'll do is, I'll put t as tan theta for simplification. And I will get the answer as x equal to sine inverse 2 tan theta upon 1 plus tan square theta. You already know all this. So sine inverse of sine 2 theta. And I end up x as 2 theta. And x became 2 tan inverse of t. I converted it back to t. Now I'll differentiate with respect to t. And my answer is 2 upon 1 plus t square. Now let me take the other function y. When I take the function y is equal to cos inverse of root 1 minus t square. One method is I can directly write cos inverse u formula and differentiate. But I want to show you how you do the substitution here. But here I'll put t as not sine. I'll not put t as tan theta. I'll put t as say cos theta or sine theta. I'll put t as sine of alpha. Both variables are different. This theta and don't put theta again here. You will get confused. So y is equal to cos inverse root of 1 minus sine square alpha. So cos inverse of cos alpha. That became alpha. That became sine inverse of t. Alpha is sine inverse of t. So dy by dt is 1 upon root of 1 minus t square. Now what I need to find? I need to find dy by dx. So what is dy by dx? Dy by dx is dy by dt divided by dx by dt. So dy by dt is 1 upon root of 1 minus t square and dx by dt is 2 upon 1 plus t square. So I can write my answer as 1 plus t square divided by 2 into root of 1 minus t square. This would be my final answer. This is how you can find. You notice that here the substitution tan theta, here the substitution is sine alpha. They both are different substitution. Now next problem I'm going to take is where both these functions are same, what to do. Now I've written another function where you notice that the substitution in both the function will be the same. So I need to put here also t as tan theta and here also I'll put t as tan theta. So in that case, the x will become sine inverse of 2 tan theta upon 1 plus tan square theta and y will become tan inverse of 2 tan theta upon 1 plus tan square theta. Now remember, both the place the angle theta is same. So x became sine inverse of sine 2 theta and y became tan inverse of tan 2 theta. Now x is 2 theta, y is also 2 theta. Now I can directly get the relationship between them. So y is equal to x. Y and x are equal because both the places are tan theta and same tan theta we applied in both the substitution. Whereas last time I put one place tan theta, other is sine alpha. So both the angles were different. So between them there was no relation. But since thetas are same here, y equal to x. So dy by dx is equal to derivative of x with respect to x. So that gives you 1. So you don't have to convert it back to theta here and find the derivative. Directly you can get a relationship between the two and then get your answer. It is not necessary every time it should be 2 theta. I could have made it as a function in 3 theta also here. So anyhow, I will be able to get a relation between x and y. Then I can differentiate and get the answer.